We're given a whole life insurance of 1,000 on age X, payable at the moment of death. Force of mortality is 0.04. Force of interest changes at time t equals 10. We want to find the probability that the present value random variable is less than or equal to 400. Okay, so for this, we know that the present value, so let's say z, is going to be 1,000 times e to negative 0.06 times tx, where tx is less than 10. And when t is greater than or equal to 10, well, we'll discount it using force of interest of 6% for 10 years, and then 3% for after 10 years. So it's going to look something like this. So we want to see when the probability z is less than or equal to 400. So we'll say this is 400, this will be 1,000. Let's look at the first condition. So case 1 will be when tx is less than 10. So if we die before 10 years, that's going to be 1,000 e to negative 0.06 tx. And we want to see when that's equal to 400, if that, or rather less than or equal to 400. Okay. So we divide both sides by 1,000, and take the log, both sides. Okay, so we get tx is greater than or equal to ln of 0.4 divided by negative 0.067. So at this point, we want to see, okay, what is the value of this? So if we enter it in the calculator, we end up getting 13.676. So clearly, that is not in our restriction here. So we want tx to be less than 10, but we found it to be greater than 10. So this doesn't make sense. So between 0 and 10, the present value will never be less than or equal to 400. So now we have to consider case 2. So tx is greater than or equal to 10. The present value, we said, is 1,000 times e to negative 0.06 times 10 minus 0.03 times tx minus 10. And we want that equal to, or be less than or equal to 400. So we'll divide both sides by 1,000 e to negative 0.06 to the 10th. So we'll have that. And we'll take the natural log of both sides. Divide by negative 0.03. And then we'll just add 10. So when we find what this is, well, we'll plug it in the calculator again. So it's ln of 0.4 times e to the 0.6 divided by negative 0.03 plus 10. We get 20.543. So we're looking at the probability of surviving 20.543 years at the time. So we're going to use the force of mortality that was given of 0.04. So this problem transforms into e to negative 0.04 times 20.543, and we end up getting 0.4397.